We're going to be doing hypothesis testing using the p-value method, and we'll also be relying heavily upon the TI-84 plus, and I'm using the CE model here. So the university I teach at, students are expected to know how to do this on a calculator because the final exam is so long, 40 to 50 questions in 2 hours, and so you've got to be able to break this down on a calculator. Okay, so in this video, we're going to be answering these 5 questions, and we're going to be using the p-value method. So first of all, with the p-value method, we have to remember what is the actual test. Well, if the p-value is less than or equal to alpha, then you reject the null hypothesis. And so the saying is, if the p is low, then the null must go. If the p is low, the null must go. And so then if your p-value is larger than alpha, you will fail to reject the null hypothesis. So what I'm going to do is I'm going to start with the first one. I think I've already got it set up. Let me see if I do. I do. Okay, so in a Rasmussen poll, 806 adults were asked to identify their favorite seat when they fly. So it looks like we're dealing with a population proportion. My sample size is 806, and my number of successes, X, is 492. Use a 0.01 significance level. That's telling you what alpha is. So I like to put alpha on the right and then the p-value on the left. And then we'll see what the symbol goes, what symbol goes in there. And then I need to write the claim in symbolic form. The claim that the majority of adults prefer window seats when they fly. So the proportion of adults preferring the window seats is greater than 50%. And that needs to be a number between 0 and 1. So that is my claim in symbolic form. Now, once I have the claim in symbolic form, I can write the null hypothesis. It's always going to be the equal sign of the original claim. And then I can write the alternative hypothesis. Now, the symbol in the original claim is allowed in the alternative hypothesis. You can only have strictly greater than, strictly less than, or the not equal symbol. So if it's allowed, you keep it. And that's what I'm going to do. I'm going to keep that symbol in my alternative hypothesis. Okay. And then that would tell me that we have a right tail test. But if we're using the 84 plus, then we don't really need to know that. But what is the command that we're going to use? Well, we have one population. And with population, everything, your test statistic is a z-score. If you're using the critical value method, they would be z-scores. And so we're going to use the one prop z-test. Well, I can't remember where the dashes are in there, but anyway. So I'm going to press stat. I'm going to come over here to tests. And I want one prop z-test. So that's number 5. And I'm going to press enter. So where it says p not equals, it wants to know what is the value of p in the null hypothesis. And that was 0.5. So I'm going to put a 0.5 in there. Okay. Get my emulator going. 0.5. Enter. Then X is, well, the number of successes, the number of people that preferred window seats, 492. And then my sample size was 806, so N is 806. And then what was the symbol used in the alternative hypothesis? Well, we used the greater than symbol. I'm going to scroll over here and press enter. Okay. Now for this one, it wants a color preference. I'm just going to go with the default and then click on calculate. Okay, so what we have is where it says P, that is our P value. This is actually our test statistic. So we don't need to use a formula to find out what the test statistic is, but we don't even need it here. And your test statistic is a z-score. Now, you have to be very careful. All right, the p-value, so let me just come back here. The p-value is not, you take p-values to 4 decimal places because they're area, or 2 times an area. The p-value is not 1.8155. That's not what it is at all. You'd be completely ignoring this bit. So what that bit means, since I've got a 10 there, I'm going to write 10 zeros. I'm going to put my decimal place there, and then I'm going to copy the rest of these numbers without the decimal place, so 181.55. And of course, if I take my p-value to 4 decimal places, it rounds to 0. So my p-value is 0. And now 0 is less than 0.01, and so my p-value is less than alpha. And so we are going to reject the null hypothesis. Okay, so now let me make some room up here. We reject the null hypothesis. And what about the original claim? The original claim, which is here, did not contain equality, because that was a strictly greater than. If it had been an equal sign or a greater than or equal sign or less than or equal sign, it would have contained equality. So the initial claim does not contain equality. So we need to know those 2 things. Why do we need to know those 2 things? Well, I'm just going to do this. So, let me come down here. Did the original claim contain the condition of equality? No, it didn't, because the original claim was P is strictly greater than 0.5. Did you reject the null hypothesis? Yes, we did, because the p-value was less than alpha. Yes, we did. And then that brings us to this result. And we're just going to, I'm going to type it. So there is sufficient evidence to support the claim that. And now I want to go back and get that claim. Everything's in English now, so we're reverting to the original English. So let me just clear this out here. Test the claim that the majority of adults prefer window seats when they fly. Okay, and so that's my result on that one. Okay. All right, so what I'm going to do now is I'm going to go to the second question. So let's come back up here. Let's copy this second question. And let's replace it. Okay. All right. So among a sample of 414 football games won in overtime, 235 were won by the team that won the coin toss. Okay, so it looks like we have another proportion, population proportion. So that's my sample size, and that's my number of successes, the number of games that were won by the team that won the coin toss. Use a 0.05 significance level. So that's what my alpha is. And I'm going to put my p-value over here once I find it. To test the claim, now here's the tricky part. You have to put the claim in symbolic form. So we're talking about a population proportion, that the coin toss is fair in the sense that neither team has an advantage by winning the coin toss. So the coin toss has no bearing on who wins the game, doesn't give you an advantage. So your chances of winning the game are 50-50. So the coin toss just gives you a 50-50 chance. Doesn't give you a benefit, doesn't go against you. So neither team has an advantage by winning it. Okay. Now, the null hypothesis is, of course, the original claim written with equality. Already has it. And the alternative hypothesis, some books write it with an A, other books write it with a 1. Well, I look at the symbol in the original claim. That is not allowed in the alternative hypothesis. You can only have these symbols. So if this symbol is not allowed, you take its complement for the alternative hypothesis. And the complement of equals is not equals. Of course, then you would have a two-tailed test. But you actually don't need to know that if we're going to use our calculator method. All right, so once again, I'm going to need that one prop z test, so stat. Go to tests and then go down to number 5. Okay, so I'm using one prop z test again. And you can see all of my data from the previous problem is stored there. So it just so happens that P0, my amount, what P is equal to in the null hypothesis is the same, 0.5. But now X here in this problem is 235. So I'm just going to write over that. So I'm going to come down here and go 235. Okay. And then my sample size is 414. Okay. And then the symbol that was used in the alternative hypothesis is the not equal symbol. So that's what I need to have. And then I'll just stay with the color blue and come down here and calculate. Okay. So again, that is my test statistic, but I don't need it for this problem. What I need here for the p-value method is the p-value. And so the p-value, if I take it to 4 places, is 0.0059. So I'm going to put it up here, 0.0059. And we can see 0.0059 is a smaller number than 0.05. So once again, we are in this situation. Okay. So I've rejected the null hypothesis. But now the original claim does contain equality. Okay, so I'm going to get rid of all of this now. And we're going to go down there and get our wording of the final conclusion. Okay. So I need those two things that I've kept up here at the top. Okay, so we start here. Does the original claim contain the condition of equality? Yes, it did. Did you reject the null hypothesis? Yes, we did. And so this is the wording that we're going to need for our conclusion. So I'm going to type it down here. There's sufficient evidence. And make sure you copy it exactly to warrant rejection of the claim that, and let me get rid of this, of the claim that, and the original claim was that the coin toss is fair in the sense that neither team has an advantage by winning it. So there's sufficient evidence to warrant rejection of the claim that the coin toss has no effect, that the coin toss has no advantage. So that, oh, let me get up here. It doesn't matter who wins the coin toss with respect to winning the game. We're rejecting that. Okay. All right. So that's that one. And I'm going to come up here and I'm going to go to the next one, which is number 3. All right, let's look at this one. I'm going to come down here. And I'll get rid of that one. Okay, let's start with this one now. Have a little bit more room up there. Okay. All right, goodie-o. Okay. A sample of 48 departure delay times, okay, has a mean. So that is the sample mean, and the sample mean is X bar. And the sample has a standard deviation of 30.8. So it's the sample standard deviation, not the population standard deviation. And nowhere in there are we told the population standard deviation. So sigma is unknown. So we have a population mean with sigma unknown. And so your test statistic is going to be a t-score. And you will need to use the command t-test. Use a 0.01 significance level. Okay, so alpha is going to be 0.01. So I'm going to write my p-value over here. Oh, sorry, I want to write it like that. And then I'm going to write my p-value here, and I'm going to compare them. To test the claim, all right, what is the claim in symbolic form? That the mean departure delay time for all such flights is less than 12 minutes. Okay, that's my claim in symbolic form. All right, so my null hypothesis will be the original claim written with equals, and this symbol is allowed in the alternative hypothesis, so I will keep it. So I have a left-tailed test, but we don't need to use the left-tailed test. Okay, so I should have everything. Oh, and if you're working with t-scores, you need to know degrees of freedom. So degrees of freedom are going to be 47 n minus 1. Okay, so let's come here, press stat, go over to tests, and we want t-test if we have a population mean with sigma unknown. Now it's asking me, were you given the raw data or summary statistics? And we were given summary statistics. So I'm going to scroll over here to stats and press enter. So now it wants to know what was the value of mu in your null hypothesis, that mu naught. And so it was 12. Okay. Then it wants to know what was the sample mean. The sample mean was 10.5. Okay. What was the sample standard deviation? So the calculator writes it S of X. I just write it with a cursive S. I don't like to write a printed S. I don't want to get it mixed up with number 5. But the sample standard deviation was 30.8. And what was the sample size? The sample size was 48. So we didn't have to actually tell it degrees of freedom because the calculator knows n, it's going to know degrees of freedom, which would be n minus 1. All right, and now the next line, it wants to know what was the symbol used in the alternative hypothesis. And you can see we use the less than symbol. So let's scroll over to where we have the less than symbol. And then I'm just going to scroll down to calculate. Okay, so we have a negative test statistic that is a t-score, which is what we expected with the left-tail test. But here's what we want. This is our p-value. So if I take that to 4 places, that 5 is going to bump that 6 up. So I'm going to get 0.3687. And 0.3687 is a bigger number than 0.01. So we are in this situation. Okay, so now what we need to know to get the conclusion is, did the original claim contain equality? No, it did not. It just had the strictly less than symbol. So the original claim did not contain equality. And we failed to reject. We did not reject the null hypothesis. That's what we'll need when we're going to type up what our conclusion is. We can use this chart down here. Okay, so let's go down to the chart now. Did the original claim contain the condition of equality? No, it did not. Did you reject the null hypothesis? No, we did not. And so this is going to be the wording of our final conclusion. Let me get that. There is not sufficient evidence to support the claim that. And then let me erase these now. And let's come up here to the original problem. There is not sufficient evidence to support the claim that the mean departure delay time for all such flights is less than 12 minutes. So no symbols in the final claim, all in English. So just because your sample had a mean delay of 10.5 minutes, there wasn't enough there to make the claim that the mean departure delay time for all of the flights was less than 12 minutes. Okay. All right. Moving onward. We've gotten over the hump now. Let's go to problem 4. Okay. Take a screenshot of that and come back down here. Now, if you've watched the video I made on the critical value method, they were the exact same 5 problems. And so if you've done the critical value method correctly and the p-value method correctly, you should be getting the same results. Okay, so that's another video on the critical value method or the traditional method. A sample of 82 actresses. So that's my sample size. Who have won the Oscars has a mean. Okay, the sample has a mean. So that's X bar of 35.9 years. And the sample has a standard deviation of, so that's not sigma, that's my sample standard deviation. Use a 0.01 significance level. So I'm going to put my p-value there. To test the claim that the mean age of all of the actresses when they win the Oscars is 33 years old. Okay. So we have got a population mean, and nowhere have they told us what the population standard deviation is. So once again, we have mu with sigma unknown. So critical values, test statistics are going to be t-scores, and we need to do a t-test again. So use t-test. Okay, so I'm going to go to stat. I just like to start over. Stat, go over to tests, and we want t-test. And I was given summary statistics. Now, I haven't written my null and alternative hypothesis yet. I'll say that. So there's my claim. The null hypothesis is always the original claim written with equality, so nothing to change there. Now the alternative hypothesis, I look at the symbol in the original claim. That symbol is not allowed, so I use its complement. Okay, so that would lead us to a two-tailed test, but we don't even need to know that. I should have everything I need now. Okay, so the value of mu in the null hypothesis is 33. So I'm going to come over here and put 33. My sample mean is 35.9. My sample standard deviation is 11.1. My sample size is 82. So it's kept all the data from the previous problem, and I'm just writing over it. Now, what was the symbol used in the alternative hypothesis? The symbol that was used is the not equal symbol. So I'm going to float over that and highlight it, press enter. Okay, so that's what we want. Now just scroll down to calculate. Okay. And so my p-value, if I take that to four places, then that 7 is going to bump that 3 up to a 4. So my p-value is going to be 0.0204. Now 0.02 blah 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 is a bigger number than 0.01. Okay, so it doesn't even matter what came after that. Okay. All right. So the p-value is bigger than alpha And so again, we failed to reject. So I need to know, did the original claim contain equality? And yes, so the original claim does contain equality. So it contains equality if the original claim uses the equal sign, the less than or equal sign, or the greater than or equal sign. So it does contain equality, and I failed to reject. I need those when writing the final conclusion. Okay. Now I can get rid of all of that. All right, so let's come down here. Okay, so let's start. Did the original claim contain the condition of equality? Yes, it did. Did you reject the null hypothesis? No, we did not reject it. We failed to reject it. And so this is what we want to start with. So again, I'm going to type that. There is not sufficient evidence to warrant rejection of the claim that, and then we're just going to go back up here and get the original claim in English. So no symbols in your final conclusion. You want it to be all English. There's not sufficient evidence to warrant rejection. So not enough to reject it. So it's really not a definitive answer, but there you have it. Reject the claim that the mean age of actresses when they win the Oscars is 33 years old. Okay. There we are. All righty. And we come to the last one for this video. So I'm hoping these 5 examples have been enough to kind of give you a taste of the different ways these things can happen, kind of stuff that gets thrown at you. Okay, so let me come here. And I'm going to get rid of him. And last problem. Okay. A simple random sample of FICO credit rating scores is obtained, and the scores are listed below. Okay, so this time what we have is raw data. We were not given summary statistics. We have raw data. And the first thing we'll need to do is put that in a list. And the default list for your tests in the calculator is list 1. So that's what I'm going to do before I do anything else. I'm going to put that. I've got the raw data. I need to put it in a list. So I'm going to click on Stat, and I'm going to press Enter because my list should be empty. If list 1's not empty, you'd have to go out and clear it. Now this is where you must be very careful. You make one mistake when you're entering your data, and everything goes wrong. So what I like to do is when I get to the end, I double check it by going backwards. So you'll see. $779. Okay. $698. $836. $753. $834. $693. And $802. All right, now I'm going to go back up and backwards through this list. So 802, 693, 834, 753, 836, 698, 779, 818, 789, 664, 751, and 714. Okay, I'm satisfied that I've done that correctly. Okay, now let's see what kind of test we're going to use and what all information we've been given here. A simple random sample, blah, 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 is obtained, and the scores are listed below. As of this writing, the mean FICO score was reported to be 678. Assuming the standard deviation of all FICO scores is known to be 58.3. Okay, you have just been told the population standard deviation because it's not our sample standard deviation. Assuming the standard deviation of all, that's your population standard deviation. So sigma is known. And we're dealing with a population mean here. Test the claim that these sample FICO scores come from a population with a mean of 678. Okay. So since my population standard deviation is known and I'm dealing with a population mean, any critical values, any test statistic, they're all z-scores. And so we want to use z-test. Now, your p-value is never a z-score or a t-score. P-value is either an area or twice an area. But if you can remember that your test statistic, when sigma is known for a mean, is going to be a z-score, then it helps you remember which test to do. So there's our claim. Our null hypothesis, of course, is going to be the claim written with equality, so nothing to do over there. And then the alternative hypothesis, well, that symbol in the original claim is not allowed, so I take its complement, which would yield a two-tailed test, but we don't need that with the p-value method. Okay. Oh, now, what is alpha? Nowhere does it say what the significance level is. So when you are not told alpha or the significance level, then the default, what you use when you haven't been told, is 0.05. Okay. All right. So now I'm going to need the p-value. And in order to get that, I need to use z-test. Okay. So I'm going to click the stat button. I'm going to go over to tests, and right on the first one, enter z-test. Now it's asking me, were you given the raw data or were you given summary statistics? We were given the raw data, so I need to scroll over data and press enter. Okay, now here it wants to know, so I've got old data in here. What was mu in the null hypothesis? So in the null hypothesis, mu is 678. What is the population standard deviation? And we were told the population standard deviation is 58.3. And the list that my raw data is in, the default is list 1. So I'm not going to mess with it. That's why I put it in list 1. And then that frequency one, just leave those there. Don't do anything to them. They're fine. Now, what was the symbol in the alternative hypothesis? And it was on the not equal symbol, and that's where it's highlighted now. So I'm not going to change anything there. And I'm just going to come down here and calculate. Okay, we've got another situation where our p-value is going to round to 0, because again, you can't ignore that e minus 7 there. because you write 7 zeros, then put the dot there, and then copy those numbers without the 0. But if you round the p-value to 4 decimal places, then it's rounded to 0. So my p-value is 0, which is less than my default alpha of 0.05. Okay, and so if the p is low, the null must go. Okay, so did the original claim contain equality? Yes, it did. And we rejected the null hypothesis. Those are the two things I need to know when I'm writing up my conclusion. So, I think that's enough. I can scroll down now to the wording of the final conclusion. Okay. So, did the original claim contain the condition of equality? Yes, it did. Did you reject the null hypothesis? Yes, we did. And so this is going to be the start of my final conclusion. So I'm going to type those words exactly as they are. There is sufficient evidence to warrant rejection of the claim that. And so now I'm going to erase that and get back to the original claim. So there is sufficient evidence to warrant rejection of the claim that these sample FICO scores come from a population with a mean of 678. All right. So that concludes the video on using the p-value method. So I hope that those 5 examples were enough for you to kind of see the different outcomes that you can get. So if you found this video helpful, can you please give it a like and subscribe to my page, and hope to see you again and have a mathematical day.